Hi, for this video what I want to do is I want to show you how to determine if a function is even, odd, or neither using an algebraic method. So this is something that could be done graphically as well, but the purpose of this video is to show you how to do it algebraically. Alright, so what we have here is if I have an equation f of x and I plug in negative x in for x, and I get the same output, then the function is going to be even. So if my original equation equals f of negative x, then we have an even function. If it is even, then you would stop testing because it can't be both even and odd at the same time. So if it is not even, then we're going to do the test to see if it is odd. In order to be odd, the equation that I got when I plugged in negative x has to equal negative f of x, and the difference between these two is in the second one we are just changing the signs of the original equation, where in this one we are replacing x with negative x, and we are using all of our exponents to simplify or distributive property, whatever you have to do in the given equation. Okay, and then it will be neither if it is neither even nor odd. So let's look at some examples. Like I said, I always start with finding f of negative x first to test to see if it is even. And if it is even, then I stop. I don't have to test for it to be odd or neither because it can't be, it can only be one of these at a time. So if we plug in negative x, I'm going to take and replace all of my x values with negative x. And you do want to make sure that you put it in parentheses so that the exponent works on the negative. It's really important that you plug it in correctly, because if you don't realize, if you don't have these parentheses around it, then the 4 only applies to the x and not the negative. So always plug in a negative value into your equation using parentheses. All right, so let's simplify this. Remember that anytime I have an even value and I have a negative, so I have an even exponent and a negative value in front, then I'm going to end up with a positive, because a negative times a negative is always a positive, and then if I go again to a negative, that becomes negative, and then I go again to a negative, it becomes positive. So I end up with x to the 4th here. Okay, same thing here, because this is even and I'm squaring a negative x, this becomes positive x squared, so I would have negative 3x squared plus 3, and we can see that our original equation that we started with is equal to this equation when I plug in negative x. So since they are equal, this is an even function. All right, so let's look at another one and see what happens to this next equation. So my next equation that we have, or function that we have, is f of x equals x cubed plus 2x squared minus 4. So again, I always start with the test for even first. So I'm going to start with negative x. I'm going to take and replace all of my x's with negative x. Okay, and so anytime I take a negative value to an odd exponent, I'm going to end up with a negative value, because a negative times a negative times a negative is a negative. For this one, we would end up with an even value, because this is, we would end up with a positive value because this is an even number. So this would be 2x squared. And we can see that these are not equal to each other. Okay, so we know that this one is not even, so our next test is to see if it is odd. In order to determine if it's odd, we have to find negative f of x. And so what this means is I'm going to take and I'm going to multiply my original value by a negative. And so I end up with negative x cubed minus 2x squared plus 4, and then we're going to compare these two to see if they're equal. So since these two equations, I have different signs for these two, okay, these are not equal. So since neither f of x equals f of negative x, and f of negative x equals negative f of x, since neither of those are true, then we would say that this is going to be neither. So this function is neither even nor odd. Okay, so I've got one last one that we're going to check and see what happens here. Okay, so first thing, again, start with negative f of x. So when I plug negative x into here, when I take a negative value to an odd number, I always end up with a negative. Okay, for this one, I end up with negative 3 times negative x cubed. Okay, and I did just distribute that in because it worked out. I probably shouldn't have shown the work because sometimes I think that working it out makes it more difficult. But since this is a negative x cubed and this is a negative 3, a negative times a negative makes it a positive. Okay, so we can see that f of negative x is equal to negative x to the 5th power plus 3x. And so then the last thing that we want to check is what happens. So we can see that these are not equal to each other. I forgot to mention that. So we can see that those two are not equal because the signs are opposite. So we want to find negative f of x. So I'm going to just take a negative and multiply it into x to the 5th. I already changed the sign on accident. Sometimes my brain gets ahead of me. Minus 3x cubed. And then all we would have to do is distribute the negative in, and we can see that we end up with negative x to the 5th power plus 3x cubed. And so if I compare these two, we can see that these are equal to each other. So f of negative x equals negative f of x. And since this is true, we can say that this function is odd. Okay, so just to recap, if f of x is equal to f of negative x, then it's even. If f of negative x is equal to negative f of x, then you end up with an odd function. If neither of those is true, then you would put neither. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you would like me to cover, please let me know that as well.